Okay, this is our final problem. I hope you're happy with this. It's gonna be like the typical one, so it won't should not be like a lot of trouble for you. So here we go. We have a projectile that is like at the top of a 200-meter cliff. I'm just gonna write it here, and it has an angle, a velocity of 60 and an angle of 60 degrees too. Okay, and it's gonna fly all over the way until it just gets here. Okay. So what to do? We just follow the Greek recipe in which we first need to compute the the, 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 the time it takes to land, and then plug in that time into the x equation, and that'll be all for us. Okay. So I'll use a nice blue here. So from here we know that y is equal to y0 plus the initial velocity in y times t minus a half of the gravity times t squared. Okay, we can plug in some values here. We know that the final position in y is going to be 0, the initial position is 200, plus the initial velocity in y, it's going to be 60. We're in the y-axis, that means we're talking about a sine of 60 times t minus a half of 9.81 times t squared. And if we just use the general formula, or we use our calculators, we're just going to get that the first time is going to be 13.59 seconds, and the other one is going to be minus 2.99. Okay, the negative one, of course, that's not an option. I'm going to write a sad face. Don't use it, or this sad face will even get sadder. This is a good one. I'm just going to write a check mark. So here we use that time and we plug it into the other equation, that is the one with the x-axis. Okay, so I'm just going to use orange pen now, and here we go. So the x is equal to the initial position in x plus the initial velocity in x times time. Remember that in the x-axis, velocity is constant, so there's no acceleration. So we don't know the x, it's still a variable, we don't know it. Initial position is 0. Initial velocity in x is 60. We're in the x-axis, that means that we're talking about cosines of theta. That theta is 60 degrees times t. T is 13.59, and that would be right here. After doing all the math and plugging those things in the computer, the result is 907 meters. So where's my plan? Here it is. And there we go. So this is the last problem that we're going to do about movement in two directions. So next, I need you to do a homework, and that's what the next video is going to be about. Homework.